Hello, everybody. It is me, Mike, and I am back, and I hope you're having a wonderful day so far. I am currently in my room, and I'm ready to study. I hope you guys are too. I took yesterday off. I know I said I'm going to keep going, but I did take yesterday off. It was Friday. It was after work, a long week at work, getting some projects done, and I just wanted to relax, spend time with my dog, and anyways, but back here on this sunny Saturday to continue the Python crash course by Eric Matisse, however you pronounce it. Still don't know to this day. But today we are on chapter 8, again of the third edition. Chapter 8 is going to be on page Saturday to continue the Python crash course by Eric Matisse. All right, I had my stream going in the background. I apologize for that. Let me go ahead and also put on Do Not Disturb here. Cool. So I wanted to just quickly check on the stream just to make sure I had. Ooh, I did not mean to do that. Make sure I had everything in order here. Oop, whoops. Keep goofing stuff up here. My fault, everybody. Okay. We are back here. Go ahead and bring this back to how I had it. All right. Technical difficulties, but we got that sorted out. I just wanted to bring this over so I could just see it here. Sweet, that looks really good. Okay, awesome. All right, my bitrate is doing pretty good at 20,000. So honestly, if the quality, let me know how the quality is, and I'm trying to work on that, get the quality better for the stream. I don't want it to be that blurry. It's really crisp on my screen, but in the stream, sometimes it can be a little bit fuzzy, and I've been trying to get rid of that. We got, all right. Let's go ahead and get started here. So yeah, we are on chapter 8, which is going to be page 129 of the third edition. I have it loaded up here onto the PDF like we did last time. I like this format. I kind of changed up the sizing of the the stream setup here so I could have more room for you guys to see the actual PDF here. And for the most part, I'm going to try to kind of go along the PDF and work along it with you guys. Pardon me. All right, so chapter 8 today. So in this chapter, you'll learn to write functions, which are named blocks of code that are designed to do one specific job. I believe we already have this, yes. Perform a single related action. We have a function definition here already. When you want to perform a particular task that you've defined in a function, you call that the function responsible for it. You call the function responsible for it. Okay. If you need to perform that task multiple times throughout your program, you don't need to type all the code for the same task again and again. See, I think this has a slightly different wording here. If you need to perform that task multiple times throughout your program, you don't need to type all the code for the same task again and again. You just call the function dedicated to handling that task, and the call tells Python to run the code inside the function. You'll find that using functions makes your program easier to write, read, test, and fix. In this chapter, you'll also learn a variety of ways to pass information to functions. You'll learn how to write certain functions whose primary job is to display information, and other functions designed to process data and return a set of value of set of values. Okay, so you'll learn how to write functions whose primary job is to display information, or other functions whose return values. Finally, you'll learn to store functions in separate files called modules to help organize your main program files. Okay, cool. Let's continue. So, defining a function here. Sorry about that. Let me turn down my volume a little bit. Here's a simple function named greetUser that prints a greeting. So def greetUser, display a simple greeting, print hello, and then greetUser. Okay. This example shows the simplest structure of a function. The line 1 uses the keyword def to inform Python that you're defining a function. This is the function definition, which tells Python the name of the function and, if applicable, what kind of information the code needs to do its job. The parentheses hold that information. In this case, the name of the function is greetUser, and it needs no information to do its job, so its parentheses are empty. Okay, so let's go back and read that one more time. It said, the parentheses hold that information. So, if applicable, what kind of information the function needs to do its job. Okay, so it's optional. The parentheses hold that information. In the case that the name of the function, is greetUser, in this case, the name of the function is greetUser and it needs no information to do its job, so its parentheses are empty. Even so, the parentheses are required. Finally, the definition ends in a colon. Any indented lines that follow def greetUser make up the body of function. The text at line 2 is a comment called a docstring, which describes the function does. Docstrings are enclosed in triple quotes, which Python looks for when it generates documentation for the functions in your program. Okay. The line print hello is the only line of code in the body of this function. The line print hello is the only actual line of code in the body of this function. So greetUser has just one job, print hello. When you want to use this information, you call it. A function call tells Python to execute the code in the function. To call a function, you write the name of the function, followed by any necessary information in parentheses, as shown at line 4. Because no information is needed here, calling our function is as simple as entering greetUser. As expected, it prints hello. Okay. That's simple enough. Passing information to a function. Modified slightly, the function greetUser cannot tell the user hello, but also greets them by name. Can not only tell the user hello, but also greets them by name. For the function to do this, you enter the username in parentheses of the function's definition at greetUser. By adding username here, you allow the function to accept any value of username you specify. The function now expects you to provide a value for username every time you call it. When you call greetUsername, you can pass in a name such as Jesse inside the parentheses. So def greetUser with the condition of username. Display a simple greeting in the docstring. Print hello username.title greetUser Jesse. Entering greetUser Jesse calls greetUser and gives the function the information needed to execute the print call. The function accepts the name you passed it and displays the greeting for that name. Hello Jesse. Likewise, entering greetUser quote-unquote Sarah calls greetUser, passes it Sarah, and also prints hello Sarah. You can call greetUser as often as you want and pass it any name you want to produce a predictable output every time. Okay, so it's passing it something. In the preceding greetUser function, we define greetUser to require a value for the variable username. Once we called the function and gave it information, a person's name, it printed the write greeting. The variable username in the define. I cannot read today. I'm sorry, guys. The variable username in the definition of greet user is an example of a parameter, a piece of information the function needs to do its job. The value Jesse in greet user, quote, Jesse, is an example of an argument. An argument is a piece of information that's passed from a function to call to a function. So the variable username in the definition of greet username is an example of a parameter. But then the value Jesse in greet user. Okay, so it's saying that you define this as a parameter. You have to have a parameter username included in the function to call it. Now, a argument is the actual argument that you're calling in place of the parameter. So they're kind of interchangeable, but they have distinctions. When we call the function, we place the value we want the function to work with the parentheses. In this case, the argument, quote, Jesse, was passed to the function greet user, and the value was assigned to the same parameter username. Yeah, so the argument gets assigned to the parameter, because the parameter represents some sort of information that needs to be called into the function. People sometimes speak of arguments and parameters interchangeably. Don't be surprised if you see the variables in a function definition referred to as arguments, or the variables in a function call referred to as a parameter. People sometimes speak of arguments and parameters interchangeably. Don't be surprised if you see the variables in a function define. People sometimes speak of arguments and parameters interchangeably. Don't be surprised if you see the variables. Yeah, that's just what I said earlier. Okay. So the try it yourself here is 8-1 message. So it wants us to just write a function called display message that prints one sentence telling everyone what you're learning about in this chapter. Call the function and make sure the message displays correctly. Okay. That seems pretty simple. So inside my chapter 8 file here, let's go ahead and make a new file. I want to call this mess 8-1. Okay, and then we're gonna go ahead and define a function that prints one sentence telling everyone that you learned about this chapter. Prints. Okay, so we're gonna def a function. We're gonna call it display message. Okay. That prints one sentence telling everyone what you learned about in this chapter. Call the function. Okay, so then it's just going to print I am learning about functions in chapter 8. Okay. And then we just want to call the function basically. So we're just going to do display message like so. So now if I run this program, we get it. Cool. So now let's go 8-2 here. favorite book dot py. Alright, write a function called favorite book that accepts one parameter, title. The function should print a message such as one of my favorite books is Alice in Wonderland. Call the function making sure to include a book title as an argument in the function call. Okay. So in this one, let's define favorite book. And inside we want to have a parameter rather, of title. The function should print a message as one of my favorite books is Alice in Wonderland. Okay. So print f string, one of my favorite books is Alice is title. And then, right? So we're going to fill in the parameter title with whatever the user gives when they call the function. So when we call the function, actually, favorite book, let's do Alice, quote, Alice in Wonderland. And if we go ahead and, what's my, yeah, there it goes, Alice in Wonderland. So if I go ahead, I'll just run it one more time. So one of my favorite books is Alice in Wonderland. So it puts it in there for me. Cool, so that's a pretty easy way to look at it. So passing arguments. Because a function definition can have multiple parameters, a function call may need multiple arguments. You can pass arguments to your function in a number of ways. You can use positional arguments, which you need to be the same order the parameters are written. Keyword arguments, where each argument consists of a variable name and a value, and lists and dictionaries of values. Let's look at each of these in turn. Okay. So you can have, we're going to look at things that have like multiple parameters, so like title, like font, things like that. But that was this one. So let's keep moving on here. Passing arguments. Let's look at each of these in turn. So positional arguments. When you call a function, Python must match each argument in the function call with a parameter in the function definition. The simplest way to do this is based on the order of the arguments provided. Values matched up this way are called positional arguments. To see how this works, consider a function that displays information about pets. The function tells us what kind of animal each pet is and the pet's name, as shown here. So describe animal. You're given an animal type and a pet name. So it just displays information about the pet in the doc string. And then it goes ahead and the function, what the actual function does is it prints, I have a, and then it calls the parameter animal name. And then it also prints my, or animal type, I'm sorry, my animal type. It calls it again, name is, and then it calls the parameter pet name. So then you can describe pet Harry, hamster Harry, and it will automatically fill in those given arguments correlated to the parameters in its designated positions of 0 and 1, I'm assuming. Okay, so that's interesting. It really depends on the user inputting their function correctly, though. So I wonder what happens if, to account for that. The definition shows that this function needs a type of animal and the animal's name. When we call describe pet, we need to provide an animal type and a name in that order. For example, in the function call, the argument, quote, hamster is assigned to the parameter animal type, and the argument, quote, Harry is assigned to the parameter pet name.
In the function body, these two parameters are used to display information about the pet being described. These outputs describe a hamster named Harry. I have a hamster. My hamster's name is Harry. Yeah, so that's pretty self-explanatory. Because it just is doing, this is all the function is doing, is just displaying information about a pet, and it's just calling these various variables, parameters, um, that eventually become arguments. It's got a lot of syntax, but in the gist, you you call the function, you give it what it wants, it plugs it in for you, performs what it wants on that information provided. So now we're going to talk about multiple function cells. You can call a function as many times as you need. Describing a second different pet requires just one more call to describe pet. So before we have all the same information, and now we're going to describe a dog named Wiley or Willie. Wiley, Willie, what? So in the second function call, we pass describe pet, the argument dog, and Willie. As with the previous set of arguments we used, Python matches dog with the parameter animal type and Willie with the parameter and pet name. As before, the function does its job, but this time it prints values for a dog named Willie. Now we have a hamster named Harry and a dog named Willie. So it's just showing you that you can call it multiple times. It's not limited to just one instance. Okay, so calling a function multiple times is a very effective way to work. The code describing a pet is written once in the function, then anytime you want to describe a new pet, you call the function with the new pet's information. Even if the code for describing a pet were to expand to 10 lines, could still describe a new pet in just one line by calling the function again. So it's just showing you how to be efficient with your programming and to not repeat yourself um, over and over again. Order matters in positional arguments. You can get unexpected results if you mix up the order in the arguments with a function call when using positional arguments. So in the same thing, he just swaps the instance of Harry and the Harry the hamster, um, and just makes the name come first when actually the parameter is supposed to call for the animal type first. Um, In this function call, we list the name first and the type of animal second. Because the argument quote Harry is listed first this time, the value is assigned to the parameter animal type. Likewise, quote hamster is assigned to pet name. Now we have a hamster named Harry. Now we have a Harry named hamster. So yeah, like I said earlier, this depends on the user. If you get funny results like this, check to make sure the order of the arguments in your function call matches the ordered parameters in the function definition. So it's very user dependent, which when you're trying to think about preventing errors, I don't think is the most efficient way of going about things. So hopefully we learn some other things. Keyword arguments. A keyword argument is a name value pair that you pass to a function. You directly associate the name and the value within the argument, so when you pass the argument to the function, there's no confusion. You won't end up with a Harry named hamster. Keyword arguments free you from having to worry about correctly ordering your arguments in the function call, and they clarify the role of each value in the function call. Let's rewrite pets.py using keyword arguments to call describe pets. Are free you from having to worry about correctly ordering your argument in the function call, and they clarify the role of each argument. Okay, yeah. So we're going to define a new function here. Oh, sorry, I forgot to scroll here. So we're going to define a new function of describe animal as our previous one. Okay, so I graded out animal type and pet name. Okay, so you call it specifically when you actually call the function. It's not. I thought it was going to be written into here to prevent the user from doing it. But that wouldn't make sense because it just wants to the user is explicitly telling you, like, if they didn't know the order on their head or care to look it up or learn what the order was, um, for these specific function calls, they could just, but they knew the parameter name, they could just call it in any order. Okay. So let's continue. The function describe pet hasn't changed, but when we call the function, we explicitly tell Python which parameter argument should be matched with. When Python reads the function call, it knows to assign the argument, quote, hamster to the parameter animal type, and the argument, quote, Harry to pet name. The output correctly shows that we have a hamster named Harry. The order of keyword arguments doesn't matter because Python knows where each value should go. The following two functions are equivalent. So it's just going to show you that you can call it in any order like we previously just said here. When you use keyword arguments, be sure to use the exact names of the parameters in the function's definition. Yeah, that's the only thing is if you spell these parameter names wrong or put in a different one, it's also user dependent. Default values. When writing a function, you can define a default value. Scroll up here. For each parameter. If an argument for a parameter is provided in the function call, Python uses the argument value. If not, it uses the parameter's default value. So when you define a default value for a parameter, you can exclude the corresponding argument you'd usually write in the function call. Using default values can simplify your function calls and clarify the ways your functions are typically used. Okay, for example, if you notice that most of the calls to describe pets are being used to describe dogs, you can set the default value of animal type to dog. Now, anyone calling describe pet for a dog can omit that information. So we're going to def describe pet name, and then comma animal type equals, quote, dog. Okay, and then describe pet name Willie. We change the definition of describe pet to include a default value of, quote, dog for an animal type. Now when the function is called with no animal type specified, like right here, Python knows to use the value, quote, dog for this parameter. Okay. Note that the order of the parameters in the function defined had to be changed because the default value makes it unnecessary to be specified an animal type as an argument. The only argument. Note that the order of the parameter in the function definition had to be changed. It went from pet name first. Because the default values make it unnecessary to specify an animal type as an argument, the only argument left in the function call is the pet's name. Python still interprets this as a positional argument, so though the function call is called with just a pet's name, that argument will match up with the first parameter listed in the function's definition. This is the reason the first parameter needs to be pet name. The simplest way to use this information The simplest way to use this function now is to provide just a dog's name into the function call. Describe pet, quote, Willie. The function call would have some output as the previous example. The only argument provided is Willie, so it's matched up with the first parameter in the definition, pet name. Because no argument is provided for animal type, Python goes and uses the default value dog. To describe an animal other than a dog, you would use a function call like this. Pet name equals Harry, animal type equals hamster. So would you even need to include pet name equals, or could you just say Harry and then do animal type equals hamster? Because an explicit argument for animal type is provided, Python ignores the parameter's default value. Yeah, it overrides dog and applies hamster. When you use default values for any parameter with a default value, sorry, when you use default values, any parameter with a default value needs to be listed after all the parameters that don't have default values. This allows Python to continue entering positional arguments correctly. So just put the ones with default values at the end. Equivalent function calls. Because positional arguments, keyword arguments, and default values can be all used together, often you'll have several equivalent ways to call a function. Consider the following definition for describe pet with one default value provided. Def describe pet, pet name, animal type equals dog. With this definition, an argument always needs to be provided for pet name, and this value can be provided using the positional or keyword format. If the animal being described is not a dog, an argument for animal type must be included in the call, and this argument can also be specified using the positional or keyword format. All the following calls would work for this function. So describe a dog named Willie, describe pet Willie, describe pet name equals Willie, yes. Describe a hamster named Harry, describe quote Harry hamster. You have to include hamster somehow. Okay, each of these function calls would have the same output as the previous examples. It doesn't really matter which calling style you use as long as your function calls produce the output you want. Just use the style you find easiest to understand. Avoiding argument errors. When you start to use functions, don't be surprised if you encounter errors about unmatched arguments. Unmatched arguments occur when you provide fewer or more arguments than a function needs to do its work. For example, here's what happens when you try to call describe pet with no arguments. So, and all the same thing, it's just the same describe pet, but you just leave it blank, okay? Python recognizes that some information is missing from the function call and traces, and the traceback tells us that. Type error. Two positional arguments missing. At line 1, the traceback tells us the location of the problem. Allowing us to look back and see that something went wrong in our function call. Next, the offending function call is written out for us to see in line 2. Last, the traceback tells us that the call is missing 2 arguments and reports the names of the missing arguments. If this function were in a separate file, we could probably rewrite the call correctly without having to open that file and read the function code. Python is helpful in that it reads the function's code for us and tells us the name of the arguments we need to provide. This is another motivation for giving your variables and functions descriptive names. If you do, Python's error message will be more useful to you and everyone else who might use your code. If you provide too many arguments, you should get a similar traceback that can help you correctly match your function call to the function definition. So it's basically saying use the tracebacks intuitively. They help you to see where you went wrong, but also set up your variables so that when you get them in the traceback and do have errors, that you can just quickly solve them using the hints provided. What's going on with my hair right now? Come on, get over there. Okay. I'm all confused. Okay. So, okay. Try it yourself. 8-3 t-shirt. Cool. Alright, so let's open up a new file here. 8-3 city air t-shirt. Next, write a function called make t-shirt that accepts a size and the text of a message that should be printed on the shirt. The function should print a sentence summarizing the size of the shirt and the message printed on it. Call the function once using positional arguments to make a shirt. Call the function a second time using keyword arguments. Okay, so we're going to define make shirt, and inside make shirt we're going to have two arguments. We're going to have size, and we're going to have message. Okay, we're going to print a f string that this shirt is a size, insert size here, and has a message of message. Okay. So we're going to call this function now twice. Make shirt. In the first call, we're going to call it using positional arguments. So I'm going to say we have a size medium, and it has Python programmer. Okay. In the second call, it's going to be a size large, and it's going to have a message of what's one of those cringe t-shirts from back in the day, like, let's just say I heart New York. Okay, but what we want to do is we want to call these directly as size equals, and we want to call this one as message equals. Write a function for t-shirt that accepts a size and text of a message that should be printed on the shirt. The function prints it. So now, I'm going to use this twice for both instances. And what I'm going to do is to just display that this is working. I'm going to inverse the order to show that the call order doesn't matter. And then I'm going to put, this one will be normal. Like so. So now if we run this shirt is size large and is a message. Oh, it has a message of, so I'm going to clear this out. So this shirt is a size large and has a message of I Heart New York. Cool. So next, 8-4. Large shirts .py. Modify the make shirt function so that the shirts are large by default with the message that reads I love Python. Make it. Okay, so let's take these, bring them over, and then by default, size is going to equal large, and then the message is going to be by default I love Python. So now we're just going to make an instance of a shirt, I think, probably. And then if we run this, I am missing arguments. No, it should work though. Why is it doing that? Command enter. So now we have a default shirt that's created with a blank function, no parameters given for large and I love Python as the message. Make a large shirt and a medium shirt with a default message and any shirt any size. So make a large shirt and a medium shirt with the default message. Okay, so let's make shirt. We want a large shirt. So size doesn't really matter, we don't need it. So the only thing we need in the message says okay. So that's all we need for the first one. Now we need to make one with the default message I love Python, but it's a medium shirt. So let's make shirt, and then we want to say size equals to medium, and then we want to make a third shirt of any size with a different message. Let's make a shirt of any size. I'm gonna have this one be extra large with the new message of this is a really big shirt. Okay, so now if I run this program, this shirt is a size L and has a message of I love Python by default with no parameters given. This shirt is a size medium and has a message of I love Python because the only parameter we overrode was the size default of large for medium. And then the last one we used, what was it called? Positional arguments to just enlist the order of the arguments directly rather than calling them with their keyword arguments. Okay, cool. That is that problem. So let's move on to 8-5. Cities. Py. Okay, and write a function called describe city that accepts the name and city of a country. Okay, so let's define a function called describe city, and it takes a name and it takes a country. Cool. The function should print a simple sentence such as, well, that's not that. Reykjavik isn't. What? Reykjavik is in Iceland. Reykjavik is in Iceland. Given the parameter of the country, give the parameter. Okay, so let's just first keep going here. The function should print a simple message of such as, okay, so it wants name, probably dot title,
You have to put it in, I'm pretty sure. Okay, so he wants to name is in and wants country. Okay. So given those, give the parameter for country a default value. Okay, United States of America. Call your function 3 different cities. So we're going to call it 3 different times. So describe city, describe city, and describe city. And the first call, at least one of these, at least one of which is not the default country. So country equals to country Canada. I'm gonna also override the name here to equal Toronto. So it'll say Toronto is in Canada. Toronto. A. It's gonna give me names. I'm gonna call a name. I'm gonna call it again actually, but with just to show that those, just to show that those two are the same. And then we're gonna call just quote Portland. So now if I run this, let me actually go here, I'll clear out this. Toronto or Portland is in the United States of America. I forgot that it is the. So Portland is in the United States of America, Toronto is in Canada, and Toronto is in Canada. Cool. So I just went to show you that you can just call the city function, describe city function by just plugging in the name because there is a default value. Now you want to make sure that obviously that name of that city is correlates to the default country that this function is or provided in the parameter for this argument of Portland. Now we're going to add in an argument of Toronto for name because we have to give a name, but we can optionally override country, so we give override country of Canada. And in this case, we just explicitly told both in an inverse order than what was provided to show that you can call it again in any order by explicitly telling each of them what the parameter is going to match to the argument. Cool. That is 8-5. So we are on 137 return values here. A function doesn't always have to display its output directly. Instead, it can process some data and then return a value or a set of values. The value the function returns is called a return value. The return statement takes a value. The return statement takes a value from inside a function and sends it back to the line that called the function. Return values allow you to move much of your program's grunt work into functions, which can simplify the body of your program. Okay, so returning a simple value. Let's look at a function that takes a first and last name and returns a neatly formatted full name. So we have get formatted name defined with parameter first name and a parameter last name. So in the docstring notes, it's going to return a full name neatly formatted.
So we create a variable called full name, and it is the f string of first and last name formatted. And then we're going to return the value, the variable full name, in a title case format. So we're going to then create a new variable called musician, right? Some variable musician. We're going to get a formatted name of, and then for its arguments, we're going to pass in Jimi and Hendrix, and we're going to print that musician. So we want to format the musician's name. So the definition of get formatted name takes takes parameters a first and last name. The function combines these two names, adds a space between them, and assigns the result to full name in line 1. Footnote 1. The value of full name is converted to title case and then returned to the call line in line 2. So in line 3, then, when you call a function that returns a value, you need to provide a variable that the return value can be assigned to. In this case, the return value is assigned to the variable musician. Or you could just say print get formatted name Jimi Hendrix, right? You could just call that directly, but it's a little bit more in depth. In this case, the return value is assigned to the variable musician in line 3. The output shows a neatly formatted name made up of the parts of the person's name, Jimi Hendrix. This might seem like a lot of work to get a neatly formatted name when we could just have written, quote, print Jimi Hendrix. However, However, when you consider working with a large, so this is where the functions chapter has quite a few edits from the edition 2 to edition 3. So I'm reading off of the edition 3 here, so that's why there's slight discrepancies between the words. However, when you consider working with a large program that needs to store many first and last names separately, functions like get formatted name become very useful. You store first and last names separately and then call this function whenever you want to display a full name, making an argument optional. Sometimes it makes sense to make an argument optional so that people using the function can choose to provide extra information only if they want to. You can use default values to make an argument optional. For example, say we want to expand get formatted name to handle middle names as well. A first attempt to include middle names might look like this: def get formatted name, first name, middle name, last name. In the docstring notes for the definition of get formatted name, it says that we want to return a full name neatly formatted. So we assign full name variable to the f string or formatted string of the person's name and first name, middle name, and last name, and we're going to head and return full name with a title case method. We're going to then call musician, a get formatted name on a variable musician, and input arguments John, Lee, and Hooker. And then we're going to go ahead and print musician. This function works when given a first, middle, and last name. The function takes in all three parts of the name and then builds a string out of them. The function adds a space where appropriate and converts the full name to the title case, John Lee Hooker. But middle names aren't always needed, and this function is written as this function is written would not work if you try to call it with only a first and a last name. To make the middle name argument optional, we can give the middle name argument an empty default value and ignore the argument unless the user provides a value. To make get formatted name work without a middle name, we set default value to middle name. To make it work without a middle name, we set the default value of middle name to an empty string and move it to the end of the list of parameters. Okay, so We define get formatted name as first name, last name, and at the end we have a middle name with the default value of a blank string. If middle name, print the full name, else just print first name, last name. Return full name, okay. And then we can print Jimi Hendrix and then print John Hooker Lee. Yeah. In this example, the name is built from three possible parts. Because there's always a first and last name, these parameters are listed first in the function's definition. The middle name is optional, so it's listed last in the definition, and its default value is an empty string. If the body of the function, or in the body of the function, we can check to see if a middle name has been provided. Python interprets non-empty strings as true, so the conditional test, if a middle name evaluates to true, a middle name argument in the function's call. Python interprets non-empty strings as true. Oh, so non-empty strings, or empty strings is false, okay? If a middle name is provided, the first, middle, and last function names are combined to form a full name. This name is then changed to title case and returned to the function call line, where it's assigned to the musician variable and printed. If no middle name is provided, the empty string fails at the if test, and the else block returns. The full name is made with just first and last name, and the formatted name is returned to the calling line, where it's assigned to the musician and printed. Calling the function with a first and last name is straightforward if we're using a middle name, however, we have to make sure the middle name is the last argument passed, so Python will match the positional arguments correctly. This modified version of our function works for people with just a first and last name, and it works for people who have a middle name as well. So returning a dictionary. A function can return any kind of value you need it to, including more complicated data structures like lists and dictionaries. For example, the following function takes in parts of a name and returns a dictionary representing a person. So we define a build person as first name, last name, returns a dictionary of information about the person. So returns person first, last, return, okay. So it creates a variable person, which is a dictionary. It assigns the key first to first name, and the key last to last name, and then it returns the person. Musician equals build person Jimi Hendrix print musician. The function build person takes in a first and last name and puts these values into a dictionary. The values of first name is stored with the key first, and the value of last name is stored with the key last. Then the entire dictionary representing the person is returned. The returned value is printed with the original two pieces of textual information now stored in the dictionary. This function takes in simple textual information and puts it into a more meaningful data structure that lets you work with information beyond just printing it. The strings Jimmy and Hendrix are now labeled as first name and last name. You can easily extend this function to accept optional values like a middle name and an age and an occupation or any other information you want to store about a person. For example, the following change allows you to store a person's age as well. So build person equals first name, last name, and age with the default value of none. The docstring says returns a dictionary of information about a person. Same as before, person equals first name, first keyword first is assigned to first name, keyword last is assigned to last name. If there's an age given, person's age, person, keyword age is assigned to age. Return person. Okay, and then the same thing before. We add a new parameter age to the function definition and assign the parameter to a special value, none, which is used when a variable has no specific value assigned to it. If you can think of none of as a placeholder value. In contextual tests, none evaluates to false. If the function call includes a for value for age, the value is stored in the dictionary. This function always stores a person's name, but it can also be modified to store any information you want about a person. Interesting. Using a function with a while loop. You can use functions with all the Python structures you've learned about so far. For example, let's use the getFormatedName function with a while loop to greet users more formally. Here's our first attempt at greeting people using their first and last name. So we have getFormatedName as first last name. It returns the full name neatly formatted. We have a full name equals a formatted string of first name space last name, and we return the full name title case. This is an infinite loop, so we added a while loop, and we say please print, tell me your name. F name equals input your first name, L name equals input your last name. Formatted name equals get formatted name, F name, L name, print hello, formatted name. So this is just creating a loop to constantly prompt or ask the user for their first and last name, and then it's going to, while the person is doing so, is going to continually print that person's name back to them formatted. For this example, we use a simple version of getFormatted name that doesn't involve any middle names. The while loop asks the user to enter their name, and we prompt for their first and last names separately. But there's one problem with this while loop. We haven't defined a quit condition. Where do you put a quit condition when you ask for a series of inputs? We want the user to be able to quit as easily as possible, so each prompt should offer a way to quit. The break statement offers a straightforward way to exit the loop at either prompt. Okay. So in this case, getFormatted name equals first name, last name. Return a full name, most neatly formatted. Okay, same as before, while true. So he adds just a quit, enter Q to quit, enter Q at any time to quit. And then he adds an if statement, if F name equals Q, break. And then he also adds if L name equals Q, break. We add a message that informs the user how to quit. We add a message that informs the user how to quit, and then we break out of the loop if the user enters the quit value at either prompt. Now the program will continue greeting people until someone enters Q for either name. So it's just going to keep asking the person over and over again for their name, for their first name, for their last name. It'll print out the first and last name. It'll keep asking until they enter just Q. We add a message that informs the user how to quit, and then we break out of the loop if the user enters the quit value at either prompt. Now, the program will continue to greet people until someone enters Q for their either name. Alright, we're on the try it yourself on page 141. 8-6. But that was an hour of studying here. I'm going to come back and study later tonight with another stream probably. But I'm going to go ahead and call it here, grab some dinner, and take a little break, and then come back for another hour later tonight and keep grinding away here. But thanks for watching this little afternoon stream. I appreciate it. Just learned about basic information about functions so far. Learned that we can input, there's things called parameters, which are indications needed to make the function run. And then there's arguments, which are provided by the user when they call the function to match those parameters. We can have these parameters in a designated order to be met, or we can give them key values, use keyword values to override uh, the the order. We can then also use key values to override default values provided via key values within the parameter definition of the function itself. Kind of a lot of wording there, but it should make sense if you kind of understand this and are on the same page so far. But just defining ways to alter or manipulate the function, pretty much, um, adding to the definition. But I'll be back in a couple hours to continue the stream, continue the study session for today, and continue about functions. See you guys.